always. Negative. Why negative? Is the work done by the friction taking energy or giving energy to the system? Taking energy to the system. It's going away from the system. So for this reason it's negative. So what will be the friction equal to? If I give the friction, if I said the friction is 10 Newton, you just plug it in here, 10 Newton. But I didn't give the friction. What did I give? And I didn't give the normal force, but we can find it. What did I give? The mass and the mu. If I give mu, we replace the friction by what? Mu? No. Not always is mg. I said not always is mg. Mu times what is the friction? Normal force. And the normal force is not mg always. Times delta x. Negative. Okay, what is Fn? Can I find it? Look at the picture and tell me what will be Fn. I mean, apply the Newton laws along y and tell me what is Fn. So what is Fn? Mg? F sine theta. Mg minus F sine theta. Mg, so Fn plus F sine theta minus Mg equals 0. This is the Newton's first law along y. So what will be Fn? Mg negative mu Mg minus F sine theta equal or time delta x, that will be the work. This is the work done by the force of friction, which will be a negative value. So how much will be? Negative 0.2 times 10 times 10, 100. I am using 10 for gravity. Negative 40 sine 37 times 5. Negative 0.2 100 minus the force, which the force is 40 sine 37, which is 24 times 5. And you get it from there. That's the work done by the friction, approximately. C, or A3, what is the work done by the gravity? Work done by the gravity is equal, by definition, what will be the work done by the gravity? What is the force in question? Mg times what? Displacement. Delta x, cosine of what angle between the gravity and the displacement? 90 degrees. What is cosine 90? So can you see that the gravity is not doing work when we are moving something horizontally? So it's not making any contribution to the energy. So the work done by a perpendicular force always will be how much? 0. The work done by a perpendicular force always will be 0. What is the work done by the normal force? So the work done by the normal force will be 0. Always, because the normal force always is perpendicular. The word normal said that it's perpendicular. Always, what will be the work done by the normal force? 0. The normal force never does work. And finally, how can we find the net work? Part B. How can we find the net work? What do? We add all the work. Because it's a scalar, it doesn't matter if it's along x or along y, it's a scalar. So you just find or add all work. In this case, will be the work done by F plus the work done by the friction. Remember, this is negative. So it's a negative value. Question on how to find the work done by a force that is constant. So if it's not constant, you have to find the integral. I have to give the function. But if it's constant, you apply this process. Example 2. Let's say that we have now an object that is pulled upward like an elevator. The tension is given as, let's say, the 1000 Newton. This is 100 kilograms. Let me just put it this way. 10 kilograms. The question, find the work done by each force, same thing that I did there. Find the net work. How can I find the work? So here will be, what forces are acting here? Gravity and tension. So, which work I have to find? If I am asking find the work done by each force, which work I need to find? The work done by F and the work done by the gravity. What is the work done by F by definition? Delta Y, by the way, given. Delta Y is equal to 5 meters. How can I find the work done by F? Is the definition by the work done by a constant force, and I know that is constant. So, what will be? F delta Y. In this case, cosine of what angle between F and delta Y? 0 degree. So, will be F times delta Y. Any question? You just multiply 1000 times 5 meters. So the work done by F will be 5,000 by unit joule. What another work we need to find? That's the tension. We already found. Gravity. By definition will be what? What force? mg times what? Delta y. Cosine of what angle between mg and delta y if the elevator or the object is going upward? 180. Cosine of 180? Negative 1. So will be cosine of 180. This is negative mg delta y. So is the gravity taking up energy or giving energy? When you are going up the stairs, is taking energy from you or giving energy to you? Taking energy. So you can feel when you are going up the stairs, you feel like you are giving up energy because of the gravity. When you are going down though, what is happening? It's giving to you energy, right? And you fly the stairs down, okay? Because it's giving to you energy. Okay, this is how to solve this.